Our presentation is on the brain and Hebbian learning. Hebbian learning, or Hebb's rule, is the theory that describes how when you learn something new and repeatedly practice that new skill, it becomes instinctive. This is believed to be caused by the fact that the neurons form connections with each other and grow stronger each time you practice the skill. An example of Hebbian learning is learning how to drive or learning how to ride a bike. The authors wanted to train people's brains to control sensory motor rhythms through transcranial direct current stimulation. This is done through electrodes that are placed on the skull repeatedly over the course of a month. The research question asked if certain electrical impulses could train people's brains to control their sensory motor rhythms. The researchers hypothesized that by using cathodal TDCS and anodal TDCS on the brain would improve people's ability to learn new skills.
What experimental methods were used? The first one we had was pre-screening evaluation, where patients were evaluated before the study in order to know their baseline sensor motor rhythms. Next, we had training sessions that included the TDCS stimulation. Then we had follow-up tests where SMR control was better after 30 days. Lastly, we had orthotic devices that were attached to participants' hands and recorded their muscle activity. Did what the authors find support their initial hypothesis? The author's initial hypothesis was partially supported. They found that the cathodal TDCS didn't work and also decreased their ability to gain skills. However, they found that the anodal TDCS increased this ability. They found this increase between day 1 and day 5 of the experiment. What do the author's findings mean? The authors found that the combination of anodal TDCS over M1 with training was able to improve learning of the skill to a larger degree than cathodal or sham TDCS. It was found that this effect was polarity specific. Cathodal TDCS truly decreased skill gains. 1 month later, retention of the freshly learned skill remained exceptional with anodal in comparison with cathodal or sham TDCS. Cathodal stimulation is negative stimulation that decreases neuronal activity, where anodal stimulation is positive stimulation.
What are the real-world implications for the author's findings? These findings could potentially be used in a rehab setting. For example, someone who suffered from a stroke or a similar brain injury may lose some skills that they were once able to do. As a result, they would have to go through extensive rehab to regain these skills. However, with the new findings of anodal TDCS increasing one's ability to learn new skills, using this in a rehab setting could potentially increase patients' recovery time. Our question for the class is, let's say that an SLP is working with patients that just recently had a stroke. How can the findings of anodal TDCS be applied here in order for the stroke patient to relearn speech and language? Here is our reference slide with the article that we used.